Hello everyone, it's Q again. In this video, we're going to learn about probe calibration. It's a very important process before you start to inspect parts. There are two purposes of probe calibration. First, calculation of probe diameter. Second, relative position between probes. Calibration is performed using master ball, aka reference ball. Calibration errors of the probe affects directly on the measured value, so they are very important process. Okay, let's take a look at the first purpose, calculation of probe diameter. It means calculating the actual probe diameter. You may wonder, why do I have to do this even though I know the diameter of the probe I installed? So the stylus made a contact with the part and it delivers the pressure to the module, and inside the module there's a pivot points, and then the pivot points is fall apart, then it triggers the signal, and when the signal is triggered it detects the coordinates. So that means the actual calculated probe diameter would be smaller than the actual size. So look at the importance of compensated probe diameter. There's a difference between the actual probe diameter and the calibrated probe diameter due to the deflection or probing error generated while probing. And the compensated ball diameter is calculated smaller than the actual diameter because stylus delivers the pressure and the module detects the signal, and while all these processes going and there's a deflections coming up, that's why it gets smaller. As the trigger pressure gets higher and the probe length gets longer, since the shank and stamp is thinner, differences between the actual diameter is bigger. The second purpose, calculation of probe relative position. If you're using various angles, it is necessary to calculate the relative position between each probes. After probing each angles on the master ball, there is a deviation between the first probe, which is the reference position, and then all the other probes. Center of the ball has deviation, so it has to be calculated before you use those angles. That's the process of calculation of probe relative position. Remember, the A angle, B angle, or 0 is the reference for the current group. So after calibration is done, result will come up and you can see all those values, including probe diameter, relative position, standard deviation, and sphericity, which stands for foam. So manage the standard deviation within 3 micrometers and sphericity within 5 micrometers in general. This means it can be changed under the different circumstances, such as probe gets longer, bigger size ball diameter, etc. Calibration period wise. We recommend calibrate your probe more than one time every day or before you start to inspect parts. It can be quite difficult to manage it every day, but it is recommendation. So if you can, then it's better to keep your probe as in the very newest condition, but it's not mandatory. But we strongly recommend to do the calibration if there is any collision or impact on the probe. On this page, you can see all these steps of creating a group. Please refer to this page, and I'm going to show how the steps are creating a group with a video. So as you can see on the right bottom, there's a live capture camera is on, and I'm going to show you how the steps are for the creating a group. First, install the probe, sensors, modules, and stylus, as I'm pointing it right now. And then, second, we have to install that probe on the NeuroMeasure CMM menu, and then click install CMM and probe, and the window will pop up. As you can see now, it's already set up the exactly same setting as the actual probe is. All the model sensors and stylus. 3 diameter, total length 20, stem material steel, stylus installed. So click install and then close the window. And after installation is done, click probe and then create a probe group. A message will appear. It says, would you like to locate the reference sphere position? So I haven't done it yet, so I'm going to click yes. And the reference positioning window will pop up. And then you touch one point of top of the reference ball. And the count will go up, and then click auto, and then it will automatically measure the reference ball with the 6 points. But first, there are 3 points first, and then calculate the topmost points, and then making 6 points to set up the position of the reference ball. And the reference positioning result is coming up. Diameter of the reference ball is already set up, and then standard deviation and form is appearing. And then after that, created a probe group window will appear, and then the name you can input names whatever you want, and the period is 7 days per day. And then the probe length is the CMM installation on the NeuroMeasure, so it doesn't have to be changed. And then click OK, and then as you can see, multiple probe calibration window will pop up, and then you can see all these options. But right now I'm going to show you how can you adjust the A angle and the B angle. As you can see, 7.5 degrees by, and then you can change anything you want. And then first, the probe should be 0 degree of A and B. And you can delete it just like that. But I'm going to click add 5 directions, which is very commonly used, the 5 different angles. The first one is 0, 0, and then all the other 4 different directions. And then I'm going to add A 45 degrees and B 67.5 degrees, added as a 6th position of probe angle. And after all this list is making done, and then click calibration, and then it'll automatically start multi-probe calibration. So now the first position is being calculated. Each position will make a contact with the reference ball with 6 points. Now they change it to A 90 degrees and B 0 degree. You can see the probe is avoiding the stem of reference ball automatically. And then move on to the next position. Keeping the A 9 degrees and just change it to B degrees, as in positive 90 degrees. So finish the calibration, go to the center and change it to the next position, and then go again. So this position is A 90 degrees and B is in negative 90 degrees. And then for the last sixth position, which is A 45 degrees, B 67.5 degrees. So after calibration is done, go back to probe number 1, which is A0 and B0, the reference position, and then the result will pop up. And you can see that all these names, calculated actual diameter, and then XYZ as a relative position. You can see that probe number 1 is 0, 0, 0. And then use the angles, then the deviation, and then sphericity, which is foam. You can see their standard deviation is lower than 3 micrometers, and sphericity is under 5 micrometers. If you want to see the result of the calibration again, you can click the probe menu and then probe list information, and the same window will pop up. That's it for now, and thank you for watching, and I'll be back with the next video. Thank you very much.